got this kind of funky form that I put up on a YouTube video with zero sound associated with it before. I thought I'd go and do a little tutorial on how to make this sort of thing from scratch. I'm going to start off by doing something a little bit simpler, but first just to sort of show you what this thing does, and I'm going to speed this up a little bit just to make for better television. I got these points in here that I can drag around, and what it does is that it moves around a magnet point. And each one of these little balls that you're seeing in here is going to react to proximity to those little balls. So we've got one here, we've got one over here, there's these little purple dots. And each one of these things is basically doing an if-then measurement, saying, if I'm closest to this point, make my radius of this sphere a percentage of that distance. And if I'm closer to this point, make myself a percentage of that distance to that point. And that way I can select each one of these points, and I can move them around, and then the whole form will change in association with it. You saw that it takes a little time for it to do it. So I'm going to do this from scratch with a slightly smaller set of data. And I'm just going to show you that these are families, in fact, that are all hosted on top of the nodal points of this surface. But I'm just going to go back and I'm going to do this from scratch, just to sort of show you how we get there. So just to start off with, I've got a basic surface here, and I've got a point. I'm just going to deal with one point for now. I'm not even going to think about this one. And what I need to do is I need to give myself my target, which is this guy here, and I need to give myself the place where each one of those forms is going to live. And so I'm going to take this surface, I'm going to divide it, and I'm going to make this a little bit smaller of a surface just to keep things a little bit zippier. So now I've got this grid. I need node points, because what I'm going to be doing is I'm going to be placing adaptive components on this guy and then on points here, but I don't have points yet. So I'm going to select the surface, I'm going to go to this little arrow thingy, and I'm going to go turn on nodes, like that. So now I've got my little points. And now I need to make an adaptive component that's, for now I'm going to do a two-pick, one that's going to go from the target and to the place where it's hosted. So I'm going to start a new generic family adaptive component based. So generic model adaptive, that's my guy. And starting off with a blank canvas here. And this is going to be a really dumb and simple family. It's going to be a two-pick family. So I did 2 points. I'm going to select those 2 points. Not all the planes, just the 2 points. And I'm going to make them adaptive. And I need to measure the distance between them. So what I'm going to do is I'm just going to get my measurement tool, aligned tool, and I'm going to go from the point, see it says adaptive points, to point. And I don't want to go to, here, this is the reference plane, this is a reference plane. I want the actual point, because that will give me a measurement that actually can drive other pieces of geometry. So if I selected that dimension, I can now name it, and once you name something, you have power over it. So let's call this distance. Well, let's just call it dist. And this is going to be an instance parameter because it's going to be different every time that I place it. And it's also going to be a reporting parameter. It's just going to call out information and read it back into the file about how big this distance is. Okay, so now I know how far these 2 points are across from each other. That's all well and good, but now I want to do something with it. So I'm going to give something to do with. So I'm going to get my circle tool, and I'm going to set the work plane that I'm going to draw it on to be on this second point. So I select that. Now that's my work plane. And now I'm drawing a circle. So I can just draw a circle on that point. And I'm going to make a permanent dimension there on that guy. So if I select that, I can do the same thing I did before, name that dimension. So let's call this rad for radius. And it's also going to be instance, because this is going to change for every single time that I place this family. So I'm going to go OK. So now, big deal. I've got 2 different named dimensions. Now I need to relate them to each other, right? So I'm going to go into my family types, and now I've got radius and I've got distance. Now I'm going to say that radius is a percentage of distance, or some fraction of it. Let's call it distance divided by 10. That'll be a nice place to start. We'll see how that goes. So now you see it just snapped down to 10% of this distance. Or is it 20%? What did I say? 10%. So if I go here and I move this guy, they get closer together, and therefore the circle gets smaller. If I go farther apart, it gets bigger. Pretty straightforward. So now when I take this is family 3. I'm just going to load it into my Reactor family, which was the host that we were looking at before. So now I've got this guy, right? And I can place it out here in the world like that. And big deal, now I've got a circle, right? Well, if I tab in and select that guy, oops, I've got the whole thing. There, now I've just got that point. If I move the point, we can see that the circle gets bigger and smaller depending on how far it is from this target. Well, I can do the same thing over here. So if I have family 3 over here in my browser, I can drag it in. I've got it on my tooltip. I can put it on my point, and then I can put it on this guy, right? So now it's hosted on these two things. I select that point. I can move it around, and we see that that guy moves with it. Well, now what I want to do is I want to spread it over this entire system. So I can do that pretty easily by select this family. And then up here, we've got a very subtle change in 2013, which is repeat, which is basically this little P added to what is usually the array tool. Now, if I hit repeat, what it'll do is it's going to spread this system, this loaded family over this entire system of nodes. Ta-da! And each one of these guys is, of course, measuring its distance from here back to its target. And so as I move that target point, somewhere in the middle of the field, it's going to measure itself again, and then it's going to percolate through each one of these families, of which there are 36, I think, and give you this result, right? Like that. Now, the only difference now between what I've done here and what we started off showing was that I have a slightly more complicated version of that. And we can look at that if I go and look at ball 2 times, which is the family that we started off with, which is a family that has a point in that ball geometry, and it has a second point. So if I go pick, 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 like that, now I've got this guy. Now if I pick this guy, it'll get bigger until at some point it's not as far away as this guy. This guy will become the driving point after it's far enough away. So we can also open up this family and take a look at it. And we can see that it's basically just the same logic as we were having on that family that I just made from scratch, except here what we've got, and I'll just going to hide this for a second so you can see the logic of this family. It's the same thing, just done twice. So I've got point 1, point 2, and a measurement between them. I've got point 2 and point 3 and a measurement between them. And then I've just built a little logic into the radius measurement. Same thing as before, but now I've got a circle, and I've got a circle being driven by 2 different radiuses. And I have an if-then statement. So if radius 1 is less than radius 2, it's going to use radius 1 divided by 4. And if it's not, then it's going to use radius 2 divided by 4. So basically, I can have this thing detect which one of these points is closer to it, and then make the radius a percentage of that, which gets us our result that we were seeing before. So if I go back in here, I can go and delete these guys, or I can also just replace these with something else. But I can also just take this guy, and I can say, pick new host, and I go snap, snap, snap. And it looks like I didn't really host this thing very well because it's not on center at this point, but it's a small point. And then I go repeat, and then it's going to do exactly the same thing, but now it's going to have these 2 guys guiding that sort of traction point. And you can see that basically all of these guys over here are measuring to this guy and taking a percentage of that distance. And then at some point it becomes closer to this guy and it takes measurements from it. So you can see there's like that crest in the middle where you get one closer to the other. And so, if I put these guys back in the middle, wait for it to percolate through, 3, 5%, 6%, 8%, 9%. We've got this guy that's really tiny in the middle. I can drag this guy over into the middle, do the same thing, and now we'll have like some sort of vein going through the middle here where it's high and then it gets low again. Yeah. Like so. And that's all there is to it. A hell of a lot easier to do the Reactor pattern now in 2013 with a lot of stuff. And hope that you guys can enjoy that. There's a lot of other tricks and doodles that you can do with doing these sorts of Reactor patterns. And I've shown some of this stuff in other posts. But I hope that that works for you, and try it out for yourselves. Datasets will be online for you to download.